Friends, in last lecture we have discussed about the determination of wavelength, particularly for the normal incidence. We were discussing about the diffraction phenomenon. Now we came across the criteria for a resolution. See, before going to start the resolving power of plane transmission grating, we will see what is the criteria for resolution. And before that, what is actual resolving power? See, a resolving power is nothing but an ability of an optical instrument to separate two nearby images. Or in other words, we can say that the ability of an optical instrument expressed in numerical measure to resolve the images of two nearby points is termed as its resolving power. See, if the term resolving power indicates to separate two nearby images, then what is the criteria for a resolution? The criteria for a resolution is given by the scientist Lord Rayleigh. And see, as per Lord Rayleigh, he says that the two images are said to be just resolved if the radius of the central disk of either pattern is equal to the distance between the centers of the two patterns. Now we have to discuss about the resolving power of plane transmission grating. In this diffraction chapter, we have to discuss about the resolving power of plane transmission grating as well as resolving power of a prism. Today in this lecture we will see the resolving power of plane transmission grating. See, in last few lectures we have already discussed about the plane transmission grating. The plane transmission grating is nothing but a plain glass plate. Over the plain glass plate, the number of lines are scratched by the help of fine quality of diamond, and due to which the spacing between the two lines is the formation of opaque portion, and due to which we get the pattern, diffraction pattern. Now, how this grating element, with the help of grating element, we get and what is its resolving power? Means what is the capacity, what is the ability of that particular optical instrument to separate two nearby images? We will see. Here again, see, repeatedly we are discussing about the resolving power because the question may arise in examination, what is the resolving power, or in MCQ also, the resolving power of optical instrument is that they can give four options. At that time we have to write the proper answer, that is the resolving power is defined the ratio of the wavelength lambda of any spectral line to the smallest difference in a wavelength d lambda. Lambda is the wavelength difference between the two spectral lines, that is d lambda between this line and a neighboring line such that the two lines appear just resolved. And just we have discussed the Rayleigh criterion, and it should be resolved as per the Rayleigh criterion, and so the resolving power of grating is given by lambda by d lambda. This is a resolving power. Now see friends how it gets. This is nothing but a grating element by sodium source or a monochromatic light. We are getting the resolution in this way. Here we get a central image. This P1 is a first order, P2 is a another second order and nth order we can say. This is a lambda and lambda plus d lambda. This is the angle between these two is d theta, where this whole angle is theta suffix n. This n is nothing but a screen here. Now see how it can be get. In figure xy is the grating surface. See, this is a grating surface. And Mn is the field of view of the telescope P1. The telescope P1 is the nth primary maximum of a spectral line of wavelength lambda at an angle of diffraction, that is theta suffix n. And here P2 is again another nth primary maximum of second spectral line of wavelength lambda plus d lambda at a diffracting angle theta suffix n plus d theta. Here P1 and P2 are the spectral line in nth order. See friends, these two spectral lines according to Lord Rayleigh's will appear just resolved when the position of P2 also corresponds to the first minimum of P1. Then in the case of a grating, the resolving power refers to the power of distinguishing two nearby spectral lines and is defined by, see here, resolving power Rp equals to lambda by d lambda, difference between the two wavelengths, where delta lambda is the separation of two wavelengths which the grating can just resolve. The smaller the value of delta lambda, the larger the resolving power. This should be keep in mind when the difference between the two spectral lines, that is a delta lambda, is smaller, then there is a larger the resolving power. Means the ability of an optical instrument is a large one. Then d sin theta equals to m in bracket lambda plus delta lambda. M is nothing but the order of the spectral line, and therefore d sin theta equals to m lambda plus lambda upon n. Again here resolving power equals to lambda by d lambda equals to m into n. And friends, here the quantity, that is Rp, resolving power lambda upon d lambda equals to m into n. These factors measure the resolving power of grating. See, this n is nothing but the number of lines stretched over the grating element, and this is the independent of grating constant. Therefore, we can say from this relation, the resolving power is directly proportional to. See, this resolving power lambda by d lambda is directly proportional to the order of spectrum. M is the order of spectrum and the total number of lines on the grating surface. This is N. Now, see, by which this resolving power Rp equals to lambda by d lambda equal to Mn, by which we are able here to calculate the of resolving power of a grating element. Friends, for that purpose, again you can see what is the required things. Means a ray diagram is important one. You can see this ray diagram, and by which you can say that uh, the quantity lambda by d lambda equals to m into n, which measures the resolving power of grating. And see, the resolving power of a grating is independent of the grating constant. Again, in other words, we can make a statement that high dispersive power refers to wide separation of the spectral lines, whereas high resolving power refers to the ability of the instrument to show nearby spectral lines as separate one. Friends, in next lecture we will see about the resolving power of prism. Prism is one of the another important optical instrument, and we will discuss about resolving power of prism. Thank you very much.